webinar. Today we're going to talk about what PDFA validation and PDF to PDFA conversion have in common, what makes them different, and what you should keep in mind when running these processes. We will go over our usual suspects in PDF, which are metadata, fonts, transparency, file structures, color spaces, and annotations. Finally, we'll go over user expectations versus implementation limits. But first, a few words about us, as we will be two speakers today. Matthias is my colleague at Orpalis and supervises the PDFA project, and I'm managing director of Orpalis and also a board member of the PDF Association. We're going to start with a few PDFA facts before we dive into the technical part of our presentation. PDFA is the ISO standard for archiving and long-term preservation of electronic documents. Its goal is to ensure the same visual appearance of the document over the course of time. Whatever platform or software you are using now and will use in the future, your document will look the same. So far, there are 4 versions of the standard. The first one has been released in 2005, and the latest is quite recent. If you want to sum up the goals of the specification, we could say that PDFA must contain everything needed to display the document and forbids anything that could negatively impact this display. This is why all fonts required for rendering must be embedded and meet the specification requirements. Color information must be given in a platform-independent format using calibrated color profiles. Encryption and password-protected access are forbidden. All metadata streams present in the PDF shall conform to the XMP specification, and launch, sound, movie, and certain other actions are also forbidden. If we take a quick overview of each version, we have PDFA 1, so published in 2005 and based on PDF 1.4. PDFA 1 has 2 levels, A and B. The A level, with A for accessible, aims to increase the accessibility of the file thanks to a logical document structure and necessary tags and information to help users with assistive technologies. The B level, with B for basic, only includes the necessary features needed for reliable reproduction of the document's visual appearance. PDFA 2 is published in 2011 and is based on ISO 30001, which corresponds to PDF 1.7. We find 3 conformance levels in this version, A, B, and the new level U with U for Unicode, that requires all text in the document to have Unicode mapping. So based on PDF 1.7, PDFA 2 includes all the new features of the PDF specification back then, such as transparency and optional content. An additional major feature is the option of embedding PDFA files to facilitate archiving sets of documents in a single file. PDFA 3 is published in 2012 and has the same 3 conformance levels as PDFA 2, so A, B, and U. The main difference is that PDFA 3 allows embedding arbitrary file formats, such as XML, CSV, CAD, word processing documents, spreadsheets, and others, into PDFA documents. Finally, PDFA 4 is published in 2020 and is based on PDF 2.0. The conformance levels A, B, and U are dropped and replaced by a level F, allowing files in any other formats to be embedded. Also, a new level E replaces the standard PDFE 1, which is the PDF for engineering. PDFA 4E includes rich media annotations for 3D content in U3D or PRC format and embedded files. So you can find everything about PDFA versions, levels, and more on the PDF Association website. Now I will let my colleague Matthias dive into the technical comparison of the validation and conversion processes.
Thank you, Elodie. So in order to make use of the PDFA format as intended, we need to make sure we can tell if the documents actually are PDFA documents or not. A PDF document can contain a claim of PDFA conformance using specific XMP metadata entries. However, to claim the PDFA conformance is simply not enough, because the claim does not ensure conformance, and on the other hand, not having the flag does not mean the document is not well formed to meet PDFA standards. This is where PDFA validation steps in. In order to be certain that the document meets the conformance requirements, we need to validate it against the PDFA and PDF specification, as well as some other normative references. This is a laborious process, since we need to uncover many details in the document and test each one of them against a specific set of rules. When done correctly, the PDFA validation provides automated tool to find problems before they can cause any possible damage in the future. So in other words, it can be utilized as a final check that will allow or reject document from being archived. This also means that at some point we will get some rejected files, and it is very important to find a solution to either prevent this to happen earlier in the process, or have a solution to modify and fix the files. In reality, many active PDF documents in the world are simply not fit for archiving, and most of them don't even try to claim that, as we mentioned before. They are just passed between entities as a tool to carry important information without realizing that at some point the document will need to be archived. Because of this, it is not always possible to optimize the workflows to create and maintain the document in PDFA format from the start to the finish. PDF to PDFA conversion tries to handle this problem by converting any real-world PDF into PDFA compliant document. Depending at which stage of the document life it is utilized, it ensures that following PDFA validation will succeed and that it will be accepted by any organization that has requirements for meeting such standards. Or alternatively, it can act as a supporting tool for archivation systems. This process can be fully automated for batch process solutions, and in many cases it can improve the quality of the final document, like optimizing file size, rendering consistency, etc. From a technical standpoint, in order to convert PDF document to PDFA, we need to utilize many of the same tools and processes as in PDFA validation, which makes these two tasks similar to a degree. So let's take a closer look on how these two compare. The backbone for the processes will definitely be the PDF document loading and parsing. In both cases, we need to be able to do detailed analysis of the objects and streams, but also of the file structure and syntax. And we need to check if all the features we are analyzing conform to the requested or claimed conformance specification. While this is most vital part of the both validation and conversion, it is the way the output of this analysis is handled where the differences start to show dramatically. To distinguish these two, we can start with the fact that the PDFA validation is an exact process. We have precisely defined set of rules and goals that lead to a final statement if the document is or isn't a valid PDFA document without any ambiguity. On the other hand, the PDF to PDFA conversion has many options on how to handle certain cases, and because of this it can be customized to produce the best results possible in specific use cases. As an example, the easiest way to convert any PDF or any other kind of document, to be precise, to a PDFA document is to simply rasterize all the pages and replace the previous page definitions with very simple single image based content. We can decide to transfer some of the document level information or interactive features, or we can throw it all out. This process eliminates most of the work needed for document analysis, and the results are very consistent, but it ultimately leads to a loss of fidelity, interactive features, file size increase, limited data extraction, particularly on digitally born documents. Some of these problems can be fixed by advanced post-processing techniques, like optical character recognition, to retain text extraction capabilities, or high-resolution rasterization coupled with mixed raster compression post-processing, in order to keep both the high visual fidelity and low file size. Despite the disadvantages, some users can actually prefer this approach because of the consistency, specific nature of input documents that are being processed, or because of the specific archiving strategy. The other option is to repair any problem found during documental analysis. This is a very good option for simple files with simple problems, but with more complexity, this approach can be hard to manage and can have negative impact on the consistency or overall performance of the conversion. As a hybrid approach, we can clone the document without any middle product, like in the rasterization approach, into new document, migrating all the information for each page, document level content, and interactive features, but while doing that, applying filters and corrections based on the PDFA specification rules. This approach is the most utilized across the industry and provides best results when it comes to retaining as much as possible of the original input document and at the same time ensuring the conformance of the output document. I would like to show some of the most common challenges that are faced by both validation and conversion and demonstrate how can the solution differ in complexity between the two. So let's start with something very simple and very common, metadata. Validation needs to check not only the information carried by the metadata for consistency check with the PDF information dictionary, for example, but it also needs to make sure if the metadata is a well-formed XML document and the structure and syntax of the package corresponds to the XMP metadata standards. Conversion has some options here. It can do the same hard work as validation and repair the XMP package if it's needed. But this seems a bit unnecessary if we consider that in most cases simply extracting the information from the metadata and injecting it into new well-formed XMP package is much easier and provides very consistent results. Also, in many cases, the metadata is not that important for the user, and it is simply rewritten from scratch using template approach with default or user-provided information. Another very common challenge are the fonts. Arguably, the most important feature in the PDF document, carrying the most of the information, yet there are many cases of incorrect usage. For the validation part, we can simply say that it only needs to check all the font requirements of the PDFA specification, which themselves are not that simple, of course, but they are well documented in the specification, so we need to just follow them. If we find any problems, we will simply log them and the job is done. Conversion does mostly the same, but on top of it, it needs to find a solution for every single problem that is found, which can be quite tricky in some cases. One major issue with fonts is that they are simply not embedded. Embedded fonts are essential requirement of the PDFA document because they ensure consistent reproduction of text independent on the platform and the fonts available on the system. The standard 14 fonts or PostScript fonts are still very popular, mostly because they are very easy to use and are the go-to choice for simple PDF editors. These fonts are most of the time not available on the system, but there are fonts that can be used as substitutions, and with standard font encodings, it is mostly easy problem to solve. However, the problem might become more serious when special fonts are utilized, where we are not able to find suitable font substitution on the system during the conversion time. While in most cases we are able to keep the lexical information, the visual representation can be compromised. In some extreme cases, documents can contain non-embedded CID fonts without properly defined encoding or simply with identity encoding. And in these cases, even the conversion through rasterization approach will fail to restore the document in the way the producer intended it to be. Another example of problematic font definitions are inconsistent glyph widths. This means that the widths for every character stored inside the PDF document font definition are not consistent with the width defined by the embedded font program. This problem can be introduced, for example, during PDF creation, because some of the PDF creators use the character with information in the PDF font definition as a tool to modify character spacings across the document. We can encounter missing glyphs where the embedded font does not support the requested character. This can happen with incorrect font subsetting or substitutions, or various encoding problems like forbidden utilization of encoding differences in non-symbolic TrueType fonts, or invalid or malformed CMAP or to Unicode maps. Solutions to these problems vary from more complex modifications of the content streams, custom CMAP re-encoding, to custom-built font programs modified exactly to match the embedded font requirements. Another interesting example is the transparency. This topic is subject only to the PDFA1 format, since the transparency is supported in the PDFA2 specification and beyond. Again, let's compare. Validation needs to analyze all the images, groups, XObjects, external graphic state, and annotation if they are utilizing any transparency features. This is again quite straightforward process, and after logging any problems, the validation is done. However, the conversion is quite problematic here. Simply removing the transparency can lead to complete loss of the visual appearance of the original document. In some cases, you can try to find alternatives to the transparency by features allowed in PDFA1, like for example trying to convert soft masks to stencil mask. But this is not a guaranteed outcome approach and should be configurable in the conversion process. Most attempts to fix transparency in PDFA1 are subject to potential loss of information, and ultimately the only way to fix problems is to rasterize the page. Which brings the disadvantages we have talked before, but it's definitely a better and more consistent approach to this kind of problems. File structure. This is another case where validation is doing the hard work, because the PDFA specification requires very strict formatting for header, object, and stream definitions, exact sequences of white spaces, end of line, and special characters, etc. Additionally, the nature of the PDF document requires exact positioning of the objects with respect to the cross-reference table. Small inconsistencies in the file structure can many times be ignored by the PDF processors and viewers, which will automatically restore the document to the working order. However, the validation cannot do that, and it needs to take into account all flaws and log them for the validation results. Conversion would of course be able to check and repair this, but in most cases it is not necessary, because the file is being generated from the scratch anyways. Having a proper PDF generator capabilities will ensure every object and stream will be correctly formatted, header will conform to the specified template, and cross-reference table will be precise even in case when the repair is needed for the input document. When it comes to color spaces, the PDFA specification's main requirement is to make sure the colors can be reproduced consistently on any platform and system. Because of this, we need to make sure that the document is not using device-dependent color spaces, or at least that certain conditions are met which allow this to be remapped systematically into other calibrated color spaces. The options here are to either define document output intent or default color space definitions based on calibrated color spaces. Alternatively, the document can rely solely on calibrated color spaces, but the validation needs to make sure that these are correctly defined according to PDFA and PDF specifications, and also on other required standards like ICC specifications. Conversion again can handle potential problems in different ways. In case a single device dependent color space is used throughout the document, we can simply provide a calibrated ICC profile and create corresponding output intent. Or in case we have multiple types of color spaces, we can remap them to default color spaces. Alternatively, if the precise color reproduction is not a priority for the document, we can simply use basic RGB output intent and transform the colors from the other color spaces. However, in rare cases, this approach might carry the risk of possible loss of information. Very simple example are annotations. We need to make sure the document does not contain annotation types that are not allowed in PDFA specification, such as movie, sound, 3D annotations up until the PDFA 3, or custom annotations which are quite popular. For the allowed types, we need to check if they are correctly defined and if they appear in streams with all the rendering requirements we have mentioned previously. Again, any problems are simply logged and nothing else needs to be done. The conversion needs to choose what to do with forbidden or invalid annotations. Some annotation types can be flattened, meaning the appearance stream of the annotation will be rendered directly to the page content, which will keep the visual representation but disable the interactive features. Certain features of the annotation need to be removed, like launch and JavaScript actions, which can pose security threats, and in many cases the appearance streams need to be regenerated either because they are missing or because they do not meet the specification. Last on our list of samples, but not least, are the implementation limits. PDFA specification explicitly requires that the implementation limits set by underlying PDF specification are respected in conforming documents. This means that the validator, as well as the converter, needs to test all the numeric values, strings in content streams, graphic state nesting count, or count of the indirect objects. For conversion, some of these potential problems can be very tricky to solve, because it is hard to determine if the value in question is a result of error during the document generation, or if the value is actually carrying correct information that needs to be somehow fixed or formatted in order to reproduce the content as intended by the producer. Because of this, it is inevitable that these cases will lead to loss of information, and the user should be aware of it, and if possible, you should have some options for how to handle these cases. We can sum this up with the look at what are the customer expectations for these processes. For validation, the expectations are mostly the same for all customers. As we mentioned before, validation is an exact process, and because of this, there is not much the PDFA validator can offer except of reliability and performance. On the PDF to PDFA conversion side, however, the expectations might change dramatically based on the use case. It is very important to understand if the process is deployed in automated or manual workflow, and what are the specific priorities for output of the process. Do we prioritize file size or fidelity? Do we need to keep the precise color reproduction? We have mentioned many challenges that have more than one solution, and if possible, the customer should be able to configure a certain aspect of the process. I would like to briefly mention the latest PDFA4 standard, since it is based on improved and enhanced PDF 2.0 specification. It brings new, unique challenges to the PDFA validation and conversion, and the industry is actively working on them to deliver working solutions. However, at this moment, I feel like we have a bit of a chicken egg-like situation here, because there are not many real-world documents out there, which is caused by lack of solutions and support by the vendors. As you might expect, vendors need real-world documents for building and testing solutions. So it is time to use PDFA4, and with that, I would finish my part and give final word back to Elodie.
Thank you, Matthias. Please don't forget to register for the other sessions of the PDF Days. There are many more left. You can meet us again on October 19th to talk more about our PDF solutions and what we can do to help you with your projects, no matter what your technical requirements. And before we start the questions, I would like to thank you very much for attending our webinar today. Thank you.
Thank you, Elodie. Thank you, Matos. Excuse me. I'm going to ask you to turn on your webcams now. For the attendees, you can download slides from today's presentation from the handouts panel in the control meeting in the GoToWebinar control panel. We're going to now begin to answer questions that have been submitted during today's presentation, and you can still submit questions through the questions pane in the control panel. So the first question, why is PDFA 2B most often recommended in conversion tools, would you say?
So mostly, I would say it's because of the broad adoption of the format. Previously, and obviously it was the PDFA1 which was mostly adopted, but because of the limitations brought to PDFA1 by the PDF 1.4 specification, the PDFA2 was very quickly adopted by the industry and surpassed the PDFA1. And PDFA3 is mostly the same as PDFA2, so many times people don't need to use it. So I would say that that is why PDFA2 is the most offered, because of the adoption.
So that sort of leads me to it's a good segue to the next question, which is, of all these difficulties, what's the most difficult part of dealing with PDFA?
I would say that the biggest challenges are definitely the fonts, because of we don't know what are the what are the options of the system that's handling the conversion.
and the color spaces, of course, because the documents, if they don't have the color spaces set correctly, as I said many times in the presentation, the information loss can be severe. So these are two parts that need to be done very correctly, either in the conversion, and I would say that that's most hard to deal with.
Mm-hmm. So would, next question I see here, would PDFA 2A not be preferable as it would also fulfill accessibility requirements? Preferable, I guess, to PDFA 2B.
It depends on, again, this depends on the underlying document, basically, what are we converting? If the document that we are converting already has the accessibility information, then would definitely be preferred to PDFA 2B. However, if the document that is being converted does not have the accessibility information or text structure, logical structure, then it might be challenging to do the automatic tagging of the document in the correct way, since we all know that there is a certain limit that the machine can do the tagging for us. And I think that that's why, again, the preference is on the 2B side, because it's not very often easy to do the PDFA to A conversion in all cases.
Mm-hmm. Mm-hmm. So you mentioned rasterization as a process by which, you know, very, very simple PDFA files can be produced. But are there other options when a file cannot be converted to PDFA?
Most of the time, we are, at least from our part, when we try to convert a PDF, we are trying to keep it as it is. So if we have a digital board document, we are not trying to use the rasterization and only use the rasterization as the fallback if anything fails unexpectedly. However, the other option basically is to tell the customer that, for example, we have failed because we need some specific font on the system, or in something similar, to have feedback to the customer so that he can try to fix the process on his own.